Hello students, let us understand mole concept, a very important concept to form the basis for your physical chemistry. When it comes to reactions, the mole concept is a very important concept. So if you understand a mole concept, where it is going to help us? So very importantly, it is going to tell you what is the meaning of the atomic mass. What is the meaning of atomic mass? Many students have this confusion that atomic mass and mass of one atom, lot of confusion is there. This confusion will be cleared off by using the mole concept. Again, there is molecular mass. What is the meaning of the molecular mass or mass of one atom and the molecular mass? Is it same or different? This is also a big confusion many students have. Then this is the thing, like mole concept will help you to understand this. Then there is a concepts of the limiting reagent. Like this is the basis for many reaction. Like just the way because certain amount of the reactants are supplied means this doesn't mean that all the reactant will get consumed. It will consume in certain stoichiometry. For that, limiting reagent is also very important. Then there comes the concepts of the concentration terms. Concentration terms like molality, normality, then mole fraction, mass percent, volume percent, all these things you will get to understand very nicely if you know mole concept. Now, how to start with a mole concept? What is the idea? See, when we have to count very large number of the atom and we want to break down it to smaller number. Okay, so there are certain examples which you already know. That is, like everyone knows that two items, if you want to represent two items is equal to one pair. Means the two number which was there, I have reduced to it what? Smaller number. 12 items, 12 numbers were there. The number was bigger, I reduced it to 1 dozen, right? 20 items, I am reducing it to what? 1 score. 20 items is equal to 1 score. 10 years, this is high number, value is higher. 10 years, I am saying it 1 decade. Means if I want to say 100 year, I will say 10 decade. This becomes easy saying a decade because the bigger number is becoming smaller. 100 years is equal to 1 century or 100 run is equal to 1 century, right? 100 is equal to 1 century, that bigger number 100, I am using smaller value for it. Now there comes this number 6.022 into 10 raised to 23. Now this number is specifically for the counting atoms. Why counting atoms? I'll come to this later. As of now, just try understanding what is there. I have written certain things. 6.022 into 10 raised to 23 atoms is equal to 1 mole of atoms. 6.022 into 10 raised to 23 molecules is equal to 1 mole molecule. I have written just something hypothetical over here. 6.02 into 10 raised to 23 humans is equal to 1 mole humans. This is not possible. On whole earth these many humans are not there. Okay, so we don't use it for counting humans or any other thing. We use mole only to count the number of atoms. Understand? 1 mole is equal to what? 6.02 into 10 raised to 23. 1 mole, I'll write it over here. 1 mole is equal to 6.022 into 10 raised to 23. Okay, this is the value of the 1 mole. When you say 1 mole atom, it is 6.02 into 10 raised to 23 atom. When you say 1 mole molecule, it is 6.02 into 10 raised to 23 molecule. Understand how big is this number? Number is very big. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22, 23. Number is so big. Why we are dealing with such a big number? It is because when it comes to counting the atoms or counting the molecule, a small quantity of the substance will have large number of the atoms. That is the thing, that is the whole point. That's why we are not going to say that, in small block, let's say there is a small block of the copper. Okay, there is a small block of the copper. Let's say there is a small block of copper weighing something 2 gram. A very large number of atoms will be there. I won't be using the units like 10 crore, 5 crore atoms are there in that small block of the copper, or 100 crore. I cannot use these big numbers. So we use the concept of the mole over here. Right? So when we go further, like I'll just tell you. Like you see this, there is a sodium block is there. There is potassium block, copper block is there, carbon, coal is there, gold block is there, silver block is there. You see. Now you see this is very small quantity, and if you want to count the number of atom, you cannot say every time there are 1,000 crores of atom. What you will say? Let us say that in this small block there are, can we say this? There are 1,000 crore atoms present in this. This again becomes very big number. So if I want to count a number of atoms in this, I will say that there are so and so moles, maybe 0.1 mole, 0.2 moles, 2 mole, 3 mole, this kind of things I will be using. Finally, mole is the thing where we are using it to count the larger quantities, and that small amount will have large number of the atom. That is only possible with elements. Elements have large number of atoms. Or a certain substances will have small substances, small little amount of the elements will have large amount of the molecule. That is where the concept of the mole will come into the picture. Over here, what I have written is 6.02 into 10 raised to 23 atoms is equal to 1 mole. This is a value which you have to fix in mind. 6.02 into 10 raised to 23 molecules is equal to 1 mole molecule. And 6.02 into 10 raised to 23 humans is equal to 1 mole humans. It is impossible. These many humans are not there, right? Still, if you want to use, you cannot use this. You can only use this. You can only use these for atoms, molecules, or ions. So, did you understand what is 1 mole? 1 mole is equal to 6.02 into 10 raised to 23. This is the thing. Yeah. Here you see the 23 gram of the sodium metal is there. Here there are, what is there? There is a 23 gram of the sodium metal. Means in this block there are so many atoms. There are so many atoms. All are of the equivalent size. Okay. All atoms are of the equivalent size. So how you will count that? Since there are so many atoms, you cannot again use crores and crores. You will use the concept lower unit called as mole. Right? So now we'll go ahead. Atomic masses. We'll figure it out. Over here, what is the meaning of this? Atomic masses. Here it is written atomic masses. So here atomic masses of the different element is given. So for the hydrogen, it is given to be how much? It is given to be is equal to 1 gram per mole. Means it's very clear that 1 gram is not a weight of one atom of hydrogen. It is a weight of how much? It is a weight of 6.02 into 10 raised to 23 atoms of the hydrogen. So I'll write over here. It is what? It is mass of, this is mass of 6.022 into 10 raised to 23 atoms of hydrogen. When these many atoms of hydrogen will come together, that time it will weigh 1 gram. You understand how much is a 1 gram? One atom cannot weigh 1 gram. Even 100 atoms of the hydrogen will not weigh 1 gram. Even 1000, even 1 crore atom will not weigh 1 gram. Because atoms are very, very small. So how many atoms? This. So I can also say that mass of, instead of saying these many atoms, I will say mass of 1 mole atoms of hydrogen. So over here grams per mole means it is a weight of 1 mole atoms of the hydrogen. It is a weight of 6.02 into 10 raised to 23 atoms of hydrogen, right? Further, carbon atomic mass is given as a 12 grams per mole. Now 12 grams per mole means what? It is a mass of, again, it is a mass of, I'll write this, mass of 6.022 into 10 raised to 23 atoms of carbon. See, element is changing, the number of the atoms is what? Same. That is a 6.0 into 10 raised to 23 atoms of carbon. Means, when these many atoms of the carbon will come together, that time it will weigh 12 gram. I can also say that in terms of moles, it is mass of 1 mole atom of carbon. We can say it this way. Okay. Sodium's atomic weight is 23 grams per mole. Means it is a mass of what? Mass of 6.022 into 10 raised to 23 atoms of sodium. Means over here I had written 23 gram of the sodium. Can someone comment over here and tell me how many atoms of sodium are there? Please comment and tell me how many atoms are there. You can pause this video for some time. Use the concept of the mole and the atomic masses. So 23 gram is also the atomic mass of the sodium. Means it is how many atoms are there? There are, so these atoms which are there, it is 6.022 into 10 raised to 23 atoms, right? So I'll write over here. I can also say that this is a mass of 1 mole atom of sodium. Same way calcium over here given as 40, means it is a mass of what? Mass of 6.022 into 10 raised to 23 atom of calcium, means also a mass of 1 mole atom of calcium. Hope this is clear. Right? Without problem, without solving the questions on this, the concept is, is not always clear. If you want to have the clarity of the concept, always try solving the example. You tried solving from the module or from the worksheet which I give. Try solving the example. Always solving the example, solving the problem, or taking that situation and trying to understand. That is the best revision and applying your concept. Over here the question given is calculate the number of atoms present in a 46 gram of sodium block. Atomic mass of the sodium is given to be 23 grams. Understanding? Calculate the number of the atoms present in a 46 gram of the sodium block. Understand? You have the sodium block. Everyone must have seen what is sodium. It is always kept in a kerosene in a lab. Okay, small. It is like, the shape is like a paneer, or texture is like a paneer, white, silvery white metal it is. So this is sodium. And how much is the weight? The weight is 46 gram of what? This is a sodium metal which is there, 46 gram. So you are told to find the number of the atoms present in this. Okay, number of atoms present in this. Now the concept is what? We know that atomic mass of the sodium is 23 grams. Means we have something standard. We say that 23 gram of sodium will have how many atoms? It will have 6.022 into 10 raised to 23 atoms. Clear? This is clear. Why? Why I am writing this? Because this is the definition of the atomic mass. Atomic mass means what? 23 grams per mole. Means 23 gram is a mass of 6.02 into 10 raised to 23 atoms. So, how many atoms? I am writing the weight over here. Sodium, 46 gram of the sodium will have X atoms. Is that clear? Simple cross multiplication. One is standard and other I am finding the unknown over here. So over here this will be what? 23 means you are doing it this way, 23 into X equals what? 6.022 into 10 raised to 23 into 46. So what is x is equal to? X is equal to 6.022 into 10 raised to 23 into 46 divided by 23. So this is 2. So final answer comes to x is equal to 12.044 into 10 raised to 23 atoms. Like these many atoms are present in a 46 gram of the sodium. Since the weight is almost double than the 23, so almost like it is a double the number of the atoms present in that. One more question we'll do. Calculate the number of moles of atom. Now the question is about, the earlier question was what is the number of atoms present. Now over here the question is calculate the number of moles of atom present. Right? So we know that 23 gram, like there is a sodium block whose weight is 46 gram. Now the question is not about how many atoms are there, how many atoms only, but you are asking in terms of moles, right? Means understand, there are 24 mangoes. I keep in front of you 24 mangoes and I ask you count this. How many mangoes are there? You will say 24 mangoes. And if I ask you the question, how many dozens of mangoes are there? You will say 2 dozens. Same with the previous question, I asked you how many atoms are there. Now I am asking how many moles of atoms are there. Right? So we know that in 46 gram, in 23 gram of sodium has how many moles of atom? 1 mole, right? 1 mole sodium atoms are there. 1 mole sodium atoms. Right? 23 gram sodium has 1 mole sodium atom. So 43 gram sodium will have x mole sodium atoms. Right? So over here what I am doing? 23 gram I am putting not is equal to 6.02 into 10 raised to 23. I am putting 1 mole because I am told to find what? Number of moles and not that big number, right? That is how many atoms. In terms of mole it is asked. So by doing a cross multiplication, what I will get is 46 by 23, right? Which is equal to 2 moles. Now if you relate the studies that how the number of moles are written, what is the formula? If you go to a formula, number of moles, what is the formula? N. Number of moles formula is what? What is the formula? Number of moles. How do we write that formula? Number of moles, N, is given weight upon atomic mass or molecular mass, or we can say molar mass also. Right? Are we not coming to the same formula? Over here, this is given weight, this was the given weight, and this is what? Atomic mass. So to understand the mole concept, you don't have to by heart the formulas. If you know what exactly is the mole concept, you can easily understand what is the atomic mass of one atom. We'll take one more question. Calculate the mass of one atom of carbon. Atomic mass of carbon is given as 12 gram per mole. So you can pause this video for some time and solve this. What is the mass of one atom of carbon? That is what is asked. So I'll solve this for you. We know that the mass of 6.02 into 10 raised to 23. Use this. We know that mass of 6.022 into 10 raised to 23 atoms of carbon will weigh how much? 12 gram. How do I know this? I know this from the definition of the molar mass or the atomic mass. Then what is the mass of one atom of carbon? So I will write mass of instead of 6.03, I will write over here 1 atom of carbon is equal to x gram. So what is this x is equal to x? I'll do the cross multiplication again this way and this way. So x into 6.022 into 10 raised to 23, right, is equal to 12 into 1. Therefore, x is equal to 12 divided by 6.022 into 10 raised to 23. I'll cancel this approximately. 6 2s are 2. The answer comes to 2 into this will go in the numerator. That will become 10 raised to minus 23 gram. So this makes sense. 12 gram cannot be the mass of one atom. It is a mass of 6.02 into 10 raised to 23. Over here, 2 into 10 raised to power minus 23 means 0.000000002 somewhere, like 23 decimal places. Such a low mass can be of the carbon. So this is a mass of one atom of carbon. What is this? Mass of one atom of carbon. Clear? So next, mass of an element. Over here what is given is mass of an element is mass of one atom of an element. There is element X, mass of one atom of an element X is given as 1.79 into 10 raised to minus 22 gram. Calculate the atomic mass of the element. Again, you can pause this video, apply your concept and try understanding this and check your answer. Okay, so I'll explain this. Mass of one atom of element X is 1.79 into 10 raised to minus 22 gram. Calculate the atomic mass of an element. So, atomic mass, when we talk about the atomic mass, what it is? It is mass of one atom, into 6.022 into 10 raised to 23. So what is the mass of one atom? Mass of one atom is 1.79 into 10 raised to minus 22, and this is what 6.022 into 10 raised to 23. So when you solve this, you will get the answer approximately close to 108 grams per mole, because the unit of this was in gram, this is gram, the unit of this is per mole, right? So this is 108. 108 is the mass of the atomic mass of the silver metal. Element X is a silver metal over here. So this is the thing, this is the how the relationship between the atomic mass and mass of one atom can be understood. Molecular mass. Coming to this point. Molecular mass. So water, say that there is a molecular mass of 18 grams per mole. Ammonia has 17 grams per mole. A nitrogen gas has 28 grams per mole. And it is a carbon dioxide has a 44 grams per mole. These are the reported values of the atomic masses, right? Now everyone understand the difference between atoms and the molecules. Atoms are individual. Molecule means what? This is what the molecule is. This is what the molecule is. More than one type of atoms. Alright? That is what the molecule is. Ammonia molecule is this. Then N2 molecule is this. And there is a carbon dioxide molecule. This is carbon dioxide molecule. Okay. Over here, what is given is H2O has a molecular mass of 18 grams per mole. Means it is a mass of what? It is a mass of, this is the mass of 6.022 into 10 raised to power 23. In atomic masses, it was atoms. Now over here it is molecules. So it is a mass of 6.0 10 raised to 23 molecules of H2O. Means molecules of H2O means what? Like this. This is one molecule. So when like this, how many? 6.022 into 10 raised to 23 units like this of H2O will come together. That time it will weigh how much? 18 grams per mole. Okay. Ammonia has 17 grams per mole. Means it is nitrogen is 17 and 3 hydrogen, that way it is 17. Hope you know how to calculate this. This is very simple. Or I can write over here, this is a mass of 1 mole molecule of H2O. Try understanding this. Ammonia 17 grams per mole means what? It is a mass of 6.022 into 10 raised to 23 molecules of H2O. It is a mass of 1 mole molecule of, sorry, ammonia, not, this is H2, ammonia, NH3. Again, this is mass of what? Getting? Or I can write mass of 1 mole molecules of N2. This is also a mass of 6.022 into 10 raised to 23. I can write mass of 1 mole molecules of CO2. So this is how we define the molecular masses. So when we say the molecular mass of ammonia is 17 grams per mole, means these many units of ammonia, how many? 6.022 into 10 raised to 23 units of ammonia. When these many units of ammonia will come together, that time it will weigh 17 grams. 17 grams is a very high number. One molecule cannot weigh 17 grams, right? So same way for the nitrogen, the carbon dioxide molecule. You see over here I have shown some glasses of water. Okay. Here there is one glass in which there is 18 gram of water. I am talking about only weight of the water. So how many molecules will be there of the water over here? Here there will be 6.022 into 10 raised to 23 molecules of H2O will be there. Molecules of H2O in this glass of water. Now over here water is half. Okay, glass is over here. The water weight is 9 grams. So how many molecules will be there? Since over 18 gram had 6.02 into 10 raised to 23, here it will be still less. That is 3.011 into 10 raised to 23 molecules of CO2. And over here it will be what? Again somewhere close to approximately 1.5 into 10 raised to 23. Sorry, it's not CO2, water. This is water. Molecules of H2O, right? I can also say that over here there is 1 mole H2O molecules. How many molecules are there? Instead of using this big number, I am saying there is 1 mole H2O molecule. Over here it is half of it, that is 0.5 mole. What? H2O molecule. H2O molecule. Over here still half of it, means somewhere 0.25 mole molecules of H2O. So I can say the exact numbers, I can also say in terms of moles. That is what is a definition of the mole over here is. Finally, it is helping you out. Instead of saying this big number, you can also say there is 1 mole H2O molecule. Okay, there are 0.5 mole H2O molecule. This is 0.25 mole H2O molecule. Now we'll take this question. Calculate the number of molecules present in 36 gram of water. Again, you can pause this video for some time. Take your time and solve this. Calculate the number of molecules present in 36 gram of water. So we know from the definition of the atomic masses, 18 gram is a molar mass or molecular mass. 18 gram will have how much? 6.022 into 10 raised to 23 molecules. You are told to find how many molecules are there in 36 gram of water. 36 gram will have, I will write over here, 36 gram will have how much? X molecules. Now if you do the cross multiplication, X will be is equal to how much? X will be is equal to 6.022 into 10 raised to 23 into 36 by 18, and this will be 12.044 into 10 raised to 23 molecules of H2O. In 36 gram of water, how much molecules will be there? 12.044 into 10 raised to 23 molecules will be there. Calculate the number of moles of molecules. Now over here it is a similar question, but here you don't need to find the exact number of the big number, I will say. You have to find number of moles in terms of number of moles. So we know 18 gram has how many moles? 1 mole. 1 mole H2O molecule. So 36 gram will have what? X mole H2O molecule. So what is this X is equal to? 36 by 18, which is equal to 2 moles, right? And when you can, like, this is again a given weight. If you use the formula given weight upon molecular weight, right? Also called as a molar mass of this. Fine. These are simple things, just for your understanding of the concept. Calculate a mass of 1 molecule of the water. Over here the question asked is calculate the mass of 1 molecule of water. Obviously it won't be in grams, it will be very, very less, right? Calculate the mass of 1 molecule of water. So you can again pause this video for some time. See, I'll tell you students, when you do something by yourself, you may go wrong, but you understand the mistake, where you are doing the mistake, and you don't repeat that mistake again. You have to give a try. Like, I know if you pause this video, instead of half an hour, this video will take 1 hour for you to complete. But the purpose is not just to complete the videos, it is about how much you can absorb and how much you can apply the concept. That is what you need to do, right? So take this question, a simple question, calculate the mass of 1 molecule of water. My again concept from the molar mass, we know that 6.022 into 10 raised to 23 molecules of H2O. 1 minute, what happened? Yeah. Molecules of H2O will weigh how much? 18 gram. Right? So what is the mass of 1 molecule of H2O? X gram. So what will be X is equal to? X will be 18 upon 6.022 into 10 raised to 23. I'll solve this approximately. 6 3s are 18. So 3 into 10 raised to power minus 23 gram is the mass of 1 molecule of water. You can see the value, it is so less, and that should be the value of 1 atom of the that should be the value of mass of 1 molecule. Even if it will have 2-3 atoms, molecule will have 2, 3 or 4 atoms also sometime, the weight won't be so much, like 2 gram, 3 gram, right? It will be less. So how less? How much? This is the value. Now this is the formulas. These are the formulas you can remember, or sometime without this formula, if you know the concept, things also go very well. Don't worry about this. Okay, these are the formulas you will have to understand. Next is relationship between a mole and a volume. Okay, means how the volume, and this relation is true only for gases. This is very important. This is true only for gases. Means 1 mole of any gas, 1 mole of any gas, you write V is equal to 22.4 liter, but it has a condition. The condition is 1 mole of any gas at STP occupies 22.4 liter of volume. What is the meaning of STP? The temperature is 273 Kelvin and the pressure is 1 atmosphere. Gas has the, the volume of the gas will be affected by the pressure. That's why the volume of the gas will be affected by the pressure as well as temperature. If you change the temperature of the gas, volume will change. If you change the pressure of the gas, the volume will again change. For that condition, for that thing, this is very important. What is very important? STP. Only at STP, means standard condition. At this temperature, 273.15 Kelvin and pressure 1 atmosphere. Means this is the 0 degree Celsius and this is atmospheric pressure. This is atmospheric pressure. 1 mole of any gas will occupy how much? 22.4 liter. This is fixed thing. Means if there is a gas, okay, there is a gas, and over here, let's say that there is a gas, and how many molecules are there? 6.02 into 10 raised to 23 molecules are. This gas at this condition of the temperature and pressure will occupy how much volume? 22.4 liter. Now, over here there is some data. There is some data I have. Okay. You see that the molar mass, carbon dioxide is a gas. See, only for gases, because like solids and liquid don't have any effect of the pressure and temperature. Right? So over here, carbon dioxide is a gas. The molar mass is 44 and number of moles, how many molecules are there? The number of molecules present over here is 6.022 into 10 raised to 23. Now at a condition, what is the condition? If the temperature is 273.15 Kelvin and the pressure is 1 atmosphere, that gas will occupy 22.4 liter of the volume irrespective of its molar mass. You see, whatever is their molar mass, irrespective of their molar mass, finally 1 mole of gas is occupying how much volume? 22.4 liter of the volume only. Right? So this is what you need to fix in your mind, that 1 mole of any gas, this is only for the gases, 1 mole of gas at what? STP condition, that is standard conditions of the temperature and pressure, will occupy how much? 22.4 liter only. We'll do one question. Calculate the volume occupied by 32 gram of the methane gas at STP. How you would do this? There are different ways you can do. You can pause this video again and you can give a try, because you know what is the volume occupied by 1 mole of gas. And this statement is very important, STP. If STP is not given, you cannot find if it is not mentioned, just said, calculate a volume of 1 mole of gas. No, the condition, at what condition, what temperature and what pressure, you should know, right? So at STP it is 22.4 liter. So over here, 32 gram of the methane. What is methane? Methane is this, right? What is the molar mass of methane? Carbon is 12, 4 into 1, which is equal to 16 grams per mole. Means 16 gram, so therefore number of moles will be what? Therefore number of moles will be what? Moles will be what? Given weight is 32 and this is 16. Given weight is 32 and this is grams per mole. 2 za. So this is 2. moles. This is one way you can do. So we know that 32 gram has how much? 2 moles, right? 2 moles. And I know that at STP, 1 mole of gas will occupy 22.4 liter. Then 2 moles will occupy how much? X liter. So X is equal to what? 22.4 into 2, which is equal to 44.8 liter of the volume. This was the simple thing which is expected in this problem. Very simple problem. This is for it is for building your base. Okay. Maximum. Okay. Over here, this is overall mole concept we are doing. Calculate the maximum number of molecules present. Okay. This is try solving this. This will really give you the age of the mole concept. This is not specifically only based on the mole and volume relationship. You can give a try to this. Solve this. Okay. What is asked? Maximum number of the molecules present in which option? A, B, C, D. Okay. Over here volumes are also given. No, at STP. Here also it is mentioned at STP. Okay. See, understand. You may be having a question. If the condition is not mentioned at STP, what shall we do? If the question it is not mentioned, they should at least mention the temperature and pressure, and you will be using ideal gas equation for that to finding the volume. Okay, like that is a different thing, ideal gas and thing. Someday I'll teach you about it. Don't worry. The maximum number of the molecules present in which case there will be a maximum number. Over here it is written 15 liter of H2 gas. 15 liter of H2 gas at STP. We'll solve this option A. We'll solve this option A. What we'll do is we'll find the number of moles. Number of moles is proportional to what? Number of molecules. More the number of moles are there, more number of the molecules. So we'll find the number of moles. I'll not tell you to use a certain formula. We'll use our cross multiplication method only. So over here in the option A, 15 liter of H2 at STP. So we know that 22.4 liter is equal to 1 mole. Right? Then 15 liter will be is equal to X mole. Therefore, X is equal to what? How many moles? X will be 15 by 22.4. Since like you are just question is about how maximum number of moles, I will not solve this further. We will just compare the values. B, what is the B saying? 5 liter of N2 gas at STP. We know that 22.4 liter is equal to what? 1 mole. Then 5 liter will be X mole. So X is equal to what? 5 liter by 22.4. Now among this, among A and B, A will have bigger, A will be a bigger value, A will have more number of the molecules, right? But still C and D is pending. 0.5 gram of H2. So how do you find number of moles? Number of moles of H2. Okay, cross multiplication, not going into the formula. We know H2. H2 का molar mass है 2. Molar mass of H2 is 2. Single atom is 1, H2 is 2. So 2 gram of H2 is equal to 1 mole, right? And 0.5 gram H2 is equal to X mole. Yes. Therefore, X is equal to what? 0.5 by 2. 0.5 by 2. Right? And sorry, this is C, no? This is C, option C. And last is what? D. I'll directly write 10 gram number of moles is equal to 10 gram divided by how much? O2 molar mass, 1 oxygen is 16, so 32. Right, here number of moles will be this. So in which case the number of moles are maximum. So among all these options, you like which will be the highest value? We know that among this and this is highest. Okay, we'll eliminate this. This will be 0.5 0.25, right? 0.25. Then this will be again smaller, this will be bigger than this, 5 2s and this is 5 6 1 by 3, 1 by 3, this is 0.33 somewhere. So the biggest answer, the highest answer, the number of moles will be over here. In this case, there will be a maximum number of the molecules. Take this question, pause this video for some time and go ahead. Okay, I'll solve this for you. Question asked is over here 1.8, you just need to match this. Now over here, what is Na? Na is the Avogadro number. Na is this value 6.022 into 10 raised to 23. This is also known as Avogadro Avogadro's number. Okay, so they have given 1.8 milligram, very simple. And it is, the question is not about the molecules. You have to understand over here, they have asked how many atoms will be there, number of atoms, and not about the molecules. So 1.8 milligram, we'll solve the first option A, 1.8 milligram of H2O. Okay, first we'll find number of molecules in 1.8 milligram. So we know that 18 gram has 6.022 into 10 raised to 23. What? Molecules. 23 molecules. What? 18 gram of water. 18 gram H2O. 1.8 milligram means it is 1.8 into 10 raised to minus 3 gram. I will write over here 1.8 into 10 raised to minus 3 gram will have X number of molecules. So what is this X will be is equal to? It will be 1.8 into 10 raised to minus 3 upon 18, right? And into 6.022 into 10 raised to 23. Means I will write over here this same as, I can write this as Na because Na is same as, because Na is mentioned in the options. So I will write over here Na. So this will be 18 into 10 raised to minus 4 upon 18 into Na. Therefore, number of molecules is what? X is equal to 1 into 10 raised to minus 4. Now one molecule has how many atoms? One molecule of H2O has 3 atoms together. So what will be the number of atoms? Therefore, number of atoms will be what? 3 into 10 raised to minus 4. Okay, one option is there. Yes. So A is what? A is 3. A is 3. 9.8 milligram of the sulfuric acid. 9.8 milligram of sulfuric acid. So what is sulfuric acid? H2SO4. In one molecule, how much? 9.8 milligram. 9.8 milligram. So molecular mass or molar mass of sulfuric acid, if you calculate, it comes to 98 grams per mole. So 98 gram has how much? I will write Na only. Instead of 6.02 into 10 to 23, I am writing Na because that is what is given in the option. So 9.8 milligram will be what? 9.8 into 10 raised to minus 3 gram will have X. What? Molecules. So X will be what? X will be is equal to 9.8 into 10 raised to minus 3 divided by 98 into Na. Okay, and if I cancel this, and therefore X will be is equal to what? X will be is equal to 1 into 10 raised to minus 4 into Na. These many molecules are there. Therefore, number of atoms for one molecule of the H2SO4, for one molecule of the H2SO4, this is what the H2SO4 molecule is. So 1, 2, 3, 4, 5, 6, 7 are there, right? So 7. So therefore number of atoms will be what? 7 into these many molecules, that is 7 into 10 raised to minus 4 molecules. So for this B will be what? B is 4. 1.8 milligram of carbon. 1.8 milligram of carbon. 1.8 milligram carbon. I'll write 18 gram, sorry. Carbon molar mass is 12 gram. Therefore, what this is equal to Na. 1.8 into 10 raised to minus 3 gram will be X. X will be is equal to what? 1.8 into 10 raised to minus 3 upon 12 into Na. So I'll write this 18 into 10 raised to minus 3 upon 12 into Na. This is what? Number of molecules I am talking about. 6. 2s are 6. 3s are. Right? I am talking about the carbon. And what is this? 1.5. So answer over here is 1.5 into 10 raised to, this is minus 4, sorry. This is minus 4, 10 raised to minus 4. Over here carbon is always present in what form? Atomic form. Carbon never forms the molecule. So this is as it is into Na. This many number of the atoms. So 1.5 into 10 raised to minus 4. So over here C option will be 2. And obviously if you do this, option D will be 1. Only 1 is left. So A3B4, C2D1 means our option C is correct for this. Next question, what we can do is this. Correct order of the total number of atoms present in of this. So 2 moles of cyclohexane. What is cyclohexane? Cyclohexane is this. Means over here how many? C6H12. This is our cyclohexane. Total number of the correct order of total number of the atoms. So C6H12, how much is this? Molar mass. We want a molar mass. No? Number of moles we'll find first, and number of moles will tell us about how many, which one will have highest. So molar mass will be what? 6 into 12 and 12 into 1, 72 plus 12. This is 84 grams per mole. So therefore number of moles in cyclohexane, C6H12 is okay, 2 moles of cyclohexane. Why do we have to calculate? Sorry. Directly it is given 2 moles of cyclohexane. 684 gram, like this is direct 2 moles. 684 gram of sucrose. What is sucrose? C12H22O11. So what will be the molar mass of this? Molar mass of this will be 12 into 12 plus 22 into 1 plus 11 into 16. So this is 144 plus 22 and 11 into 16 is how much? 176. So 176, correct, no? This is 16 and this is 16. So 176, 22 and 144. 324. 342. 342. Therefore, number of moles in sucrose C12 or sucrose, I will write directly, sucrose will be given weight is 684 and divided by 342, 2 moles. Okay, over here also. Okay, question is about not the molecules, it is atoms. Here also I am getting 2 moles. Okay, 90.8 liter of dihydrogen. 90.8 liter of dihydrogen. H2. We know that 22.4 liter at STP. Is it mentioned at STP? Yes, it is mentioned at STP. So 22.4 liter will be 1 mole. So 90.8 liter will be what? X mole. X will be what? 90.8 divided by 22.4. Right? So how will do this? Obviously, this number of moles will be more than other, right? So 22 into 4 if I do. 4 4 is 16. Somewhere 89 means something, the value is 4 point something, 4 point something I will say. Means over here this is 4 moles. Now the question is about number of atoms they have asked. Number of atoms they have asked, in which case it will be maximum. So cyclohexane molecular formula is C6, or I'll write this independently over here. Cyclohexane is there, C6H12. How many atoms will be there? This one molecule has 18 atoms. This one molecule has 12 plus 6, 18 atoms. Then sucrose, C12H22O11 has how much? 12, 33 plus 12, 45. This has 45 atoms. And H2 has how much? 2 atoms. So total number of the atoms will be over here, it will be 6.022. Sorry, how many moles? 1 mole, sorry 2 mole. I am getting this to be 2 into 18 is equal to 36 mole atoms will be there. Mole atoms. Over here this is what? 40, again this is 2 mole into 45. So this is 90 mole atoms will be there. And what about this? This is 2 mole and 2 atoms. Sorry, 4 moles. I was getting this to be 4 moles. Close to 4 moles. So 4 into 2, 8 mole atom. 8 mole atom. So maximum atoms are there in sucrose, then cyclohexane. So sucrose, sorry, B is first. B, AC, option B, D will be correct for this, right? (2.8 into 10 raised to minus 3 moles of carbon dioxide is left after removing 10 raised to 21 molecules from it. X milligram sample. The mass of carbon dioxide taken initially is. So over here, question is there. You need to apply the concept. Question is little deep. Okay, you try solving this. Pause this video for some time. So over here the question is 2.8 into 10 raised to minus 3 moles of carbon dioxide is left after removing 10 raised to 21 molecules. Okay, so we have to understand what is the total number of moles were present. See, what is the total number of moles? The question is this way. There is 2.8 into 10 raised to minus 3 mole is left. There is a carbon sample. Let's say this is your carbon sample. Okay. And this much is left after removing how much? After removing 10 raised to 21 molecules. Right. After removing these many molecules, this is left. But over here, they have given 10 raised to 21 molecules. This is in moles and this is in molecules. If I convert these molecules to mole, I will get the total number of the moles in the initial sample. This is what? Total number. I will write total number of molecules. I will write total number of molecules in initial sample. In initial sample of carbon dioxide. One is given as 2.8 into 10 raised to minus 3 mole and other is directly given the 10 raised to 3 molecules. So what is the total number of moles in this case? Like this is already mole, I need to convert this to moles. So what is the meaning of 10 raised to 21 moles? We know that 6.022 into 10 raised to 23 is equal to what? 1 mole. And what is given in the question? 10 raised to 21 is equal to how many mole? 10 raised to 21 molecules is equal to x mole, right? X is equal to what? X will be is equal to what? 10 raised to 21, right? And divided by 6.022 into 10 raised to 23. So what will be this? X will be is equal to how many moles? It will be 1 by 6.022 into 10 raised to minus 2 moles. Right? So what I will write over here, the initial moles, so total number of moles initially was, this is 2.8 into 10 raised to minus 3 plus 1 upon 6.022 into 10 raised to minus 2, right? This is what is there. Yeah. Minus 2. So now this is also in mole. So I converted this value to this. 10 raised to 21 molecule is equal to how many mole? Right? We know that 6.02 into 10 raised to 23 is equal to 1 mole. So 10 raised to 21 will be is equal to, after doing a cross multiplication, 10 raised to 21 by this, right? These many moles. Now we need to add this. To add this, I need to make the powers equal. So we'll do this 1 by 6. Approximately I'll do, since the options are given over here. Okay. So this will be 0. I'll write over here separately. So therefore number of moles is what? 2.8 into 10 raised to minus 3 plus 0.166. Yeah, 166. So over here this is 0.166 mole. I will write this to be something 2.8 into 10 raised to minus 3 plus 1.66 into 10 raised to minus 3. So what will be this? 2.80 and 1.66 will be 4.46. So total number of the moles in the initial compound was 4.46 into 10 raised to minus 3 mole. So multiply this with the molar mass of the carbon dioxide, that is 44, right? 44. So answer will be 44. So weight will be what? weight will be 4.46 into 10 raised to minus 3 into 44. So this answer will come in gram, and this answer will be this 496.2 milligram will be the answer for this. Take this question, last question. You can take this very simple question and comment your answer over here. Thank you.